I think that should go. All right. Uh-oh. It's off. Let's see if I can. So you've already kind of heard me allude to how do we differentiate between the isotopes. Okay. So you heard me talk about carbon-12 and carbon-13. Okay. So in order to say which carbon it is, we don't have to say it's got 6 protons in it, because both of them have 6 protons in them. Okay. All we got to do is say the mass number, which is the protons plus the neutrons. So I said carbon-12 and carbon-13, mass number 12, mass number 13. That's it. And there's kind of different logistics. How do you say that? How do you say what its mass number is? You can write out the name, dash, mass number. You can write the symbol, dash, mass number. You can put the mass number in the upper left-hand corner. Okay. The last one's a little bit redundant because, carbon, mass number 12, and it's like, duh, this is the atomic number of protons. Well, it's got 6 protons if it's carbon. It's a little redundant. But sometimes redundancy is fine. But these are all saying we know that carbon can have different isotopic forms. This is saying which particular isotopic form it is. Okay, so there is no element X. But here the X is the symbol like carbon. And like I said, like you saw that last one with the carbon 12 and 6, in the upper left-hand corner you put the mass number. And if you're going to put the atomic number, put it in the lower left-hand corner. Or, lower left-hand. I guess it wouldn't be the corner, lower left-hand corner. So it looks like this. So I mentioned that your homework, you won't have to use your calculator. Okay, one of your things that you're going to be asked in your homework is to go ahead and to concisely put what isotope you're talking about, like this, in this form. So boron has 2 stable forms. The nucleus, of course, has 2 colors because you have your protons and your neutrons. The other isotopic form of boron looks kind of similar, right? But notice that it's mass number 11 versus mass number 10. Boron, the whole number for boron is atomic number 5. Okay, so of this mass number, we have 5 protons and 5 neutrons, right? Over here, for this mass number, since it's boron, we have to have 5 protons and 6 neutrons. Here's where sometimes ahead of time I'll say, now which one did I increase? Looks like the green got more abundant, right? So the green must be the neutrons. Okay. So if we had this kind of shorthand notation for this particular form of fluorine, okay, you could be asked these questions. And I'm trying to think for you guys if I do this as a test question. I think so. You can knock out those 3 subatomic particles with that shorthand notation. You wouldn't need the 9 even because the fluorine says it's atomic number 9. So how many protons does it have? 9. How many electrons does it have if it's neutral? 9. How many neutrons does it have? 10. Yeah, how'd you get 10?
Just 19 instead of 18.
Okay. I would take, what'd you say?
19 instead of 18.
It's 19 instead of 18. Oh, if it was like the same number of neutrons as protons, it would have been 18. So kick 1 up. Another way is the 19, the mass number, minus 9, the number of protons, is the number of neutrons. Yeah, same thing. Yep, exactly. Okay, so that's okay, right? I said it's neutral, and that's why you could kind of go ahead and pick off the number of electrons. It's the same as the number of protons, 9. And I guess my advice is, how do you know it's neutral? Well, and we're going to look at things that aren't neutral, but you look to see if there's any charge. So the fact that there's nothing in the upper right-hand corner means it's neutral. Any questions about that? But if you're like me, every once in a while I will break out my calculator to do this subtraction. That's how bad I am. Not that bad. Okay. So in your days in your other chemistry endeavors, I'm sure you talked about ions. Okay, and we're going to talk more about ions, why they form. But right now I kind of want to talk a little bit about ions. Ions basically means that you don't have an equal number of electrons and protons. There are ions that are just one atom called monoatomic ions. Okay, and then there are also polyatomic ions. We'll be talking more about those. I couldn't remember if I talked about those here. But the one atom, with regard to not having the same number of electrons as it does protons in its nucleus, we can go one of two ways. We can either have a positively charged ion. If it's positively charged, then means it's overload with regard to protons in its nucleus. Okay? Now, the protons in the nucleus of an atom aren't going anywhere. So it's the electrons that are going to bail. Okay? So a cation, otherwise called a cation, right, is a case where an electron has popped off, or two. And why did it pop off? And so you guys remember it wants to get a rare gas configuration or complete octet. We'll be talking more about that. The other route with monatomic ions is basically it's overload with regard to electrons. And it becomes negatively charged. We call that an anion, sometimes called an anion. So it's all about the electrons. If you picture an atom, the nucleus with the protons and the neutrons, the protons aren't going to go anywhere. The electrons can kind of come and go. So with an anion, the electrons have jumped on, again, to get that rare gas configuration. Okay, so for ions, what you're going to see in the upper right-hand corner of this shorthand notation for the isotope of this particular element is a charge. So if it's a cation, you'll see a number plus. And if there's no number here, it's implied it's just 1. And with an anion, you'll see a number with a negative sign. So here electrons have been lost, and here electrons have been gained. So E lost with a cation, and electrons gained here. Okay, so let's do one. So, again, we're going to talk about this later, but if you find calcium on the periodic table, I need to bring my pointer in here, I can see. But it's like in the second column, and actually it's just itching to lose, it's in the second column, it's just itching to lose 2 electrons. So actually that's what's happened here. Forms a +2 charge. So let's see, how many protons does it have? 20, very good. All right. How many electrons does it have? 18. Why 18?
20 minus 2.
20 minus 2. Yep. Very good. So it has 20 protons, and it has a +2 charge. So that means with regard to electrons, it must have lost 2 electrons. 18 electrons. I don't know, that's definitely not a very good factor label. 20 protons, it's an overall +2 charge, so it must have lost 2 electrons, so it has 18 electrons. All right, how many neutrons? It's always big minus little. 19, yep. Big minus little. The mass number minus the number of protons will give you the number of neutrons. Okay. Cool. Okay. Chlorine is almost to the edge of the periodic table with regard to its row. It just needs one more to get to the last column, I should say. Almost the last column, one more to get to the last column. And so it picks up 1 electron, and the fact that there's no number up here means that it's implied 1. Okay, so same deal. How many protons? 17. Very good. How many electrons? 18. Very good. Any questions about that? Good. How many neutrons? 19. Very good. Again, sometimes I get a calculator out. And so don't worry if you do too. Good. Okay. So this is how far I wanted to get. Let me double check. That's what. Yeah. Because the last topic's a good topic, but we'll need a calculator. So you won't need a calculator for any of these. Okay? Actually, kind of a light load for homework might mean you can knock out your lab write-ups. Okay?
You were thinking.
Yeah, right. So let me know if you have any questions, and that's it for today. Oh, I do want the homework. Sorry, thanks for reminding me. And it's, you know, I feel kind of odd sometimes when I grade this because some of it is much harder than others, but it's all on 10 points. So do the easy ones. Do them all the homework, but especially the easy